All right, let me try a solution here. Let's see. It looks like number 2. It says when tightening a bolt, you push perpendicular to a wrench with a force of 165 newtons at a distance of 0.14 meters from the center of the bolt. So if I were to take kind of a bolt, give it kind of a hexagonal look, and then put a wrench on it, something like this. Then what they're saying here is you apply, and it looks like we're tightening it, so I'll go this way. This is the distance away. I guess this would be the angle theta. They say the force is 165 newtons and the distance away is 0.14 meters from the center of the bolt. Now I want to take this as an opportunity to say that there's 2 ways you can calculate the torque. The first one, which we kind of derived in terms of saying that the torque depends on the force, the distance away, and the direction, we also argued that it's nice to combine, at least at times, the r and the angle theta. And when you do that, you get the r perpendicular. And what we mean by that is if you were to draw a line of action and then draw from the pivot point over so that you hit this line at a 90-degree angle, then that's the perpendicular distance, and that would take care of these 2 factors together. So that's why I said when you go to calculate torque, you really want to kind of try this if you can. Now, in this particular case, and probably because it's early on in the homework, it's only number 2, they're one and the same. You might even just say, well, maybe I'll do that one, because then that would just be the r of 0.14 meters, and then a force of 165 newtons, and then an angle of 90 degrees. In other words, the r and the r perpendicular are the same thing because we are at 90 degrees, a sine of 90 degrees. Okay, but had the force been maybe in this direction as shown in green, I would have drawn a line of action and done something like that. And that way it would have been r perpendicular. And of course we said that that's what you get when you combine them. Although we kind of derived it by having force and then the amount of force, and so we combine those 2 in the derivation. But it's nice to do a calculation with those 2. Well, like I said, whether you're thinking about torque this way or this way, they're really kind of the same thing for this particular problem. So I will go 0.14 times 165 and come up with 23.1. So 23.1, and it would be in the units of a force Newton and distance meters. Then it says convert this torque into foot-pounds. All right, so maybe I'll put a little A here, and here's B. And so I have the 23.1 Newton meters. And like any of our unit conversion, we want to get rid of something and replace it with something else. And it sounds like we want to get rid of newtons and replace it with pounds, because they want this in foot-pounds. So we put the newtons on the bottom, we put the pounds on the top. That way newtons will cancel, be left with pounds. Of course, pound meters at this point. But we got to make sure that we have a ratio that what's on the top is the same as what's on the bottom. And so converting from the English system, sometimes called the engineering system, over to the metric system, there is 1 pound is equal to 4.45 newtons. So that would convert it into pounds. Now, the other thing I'd like to do is get rid of meters and eventually get it to feet. And I suppose I could just look up how many feet are in a meter. It's something like 3.28 or something like that. But I know this, that 1 meter is 100 centimeters. And 2.54 centimeters is 1 inch. And then finally, 12 inches is 1 foot. So the meter would cancel off, then the centimeter would cancel off, then the inches would cancel off. And so after I do all this arithmetic, and notice unit conversion, that's equal to 1, that's equal to 1, that's equal to 1, that's equal to 1. So I'm just taking that number and multiplying by a bunch of 1s. That's why it is still equal to that. But these 1s convert from newtons into pounds, and then meters into centimeters, and then centimeters into inches, and then inches into feet. So you're going to get so many foot-pounds. All right, so let's see, I got that in my calculator already, so I'll divide by 4.45. I'll multiply by 100. I will divide by 2.54, and I will divide by 12. So 17.0 foot-pounds would be the torque setting in the engineering unit, or the standard unit, or the English unit, as it often is given. All right, and that's it. Take care.